Okay, it is 10:30 and we're going to start with our next presentation, who is Dr. Sello Maboe, and he is the Technical and Marketing Manager at OBP. Dr. Sello is going to discuss EBL, or exotic bovine leukosis, the impact thereof on the immune system of the dairy cow, and maybe on our industry as a whole. Dr. Sello, we're looking forward to your presentation. Thank you once again for your time, because I know you've been so busy with the students this week. And so we appreciate the hour that you've set apart for us and for the students for this presentation. Thank you very much.
Thank you, Helene. I'm going to try and take my earphones off. They're fiddling with me a bit, but if I battle to hear you guys or we battle to hear each other, I will quickly put them on.
Okay, you can continue, as it will only be you who's talking, and at the end, if there's any questions, I will talk to you, and I'm sure everything will be fine.
Thank you.
Okay.
I'm going to be talking to you today about bovine leukemia virus. Can it be a major silent threat to our business as it stands? I've tried to organize and give it a little bit of a structure, but towards the end, I will juggle a few things around, but we're going to try and follow this order, at least for now. So you guys have been, like I said, adequately fed from the nutrition side. You've had enough also from the health side. I'm not so sure how much on the genetic side, but we need to at some point also bring all these together, because they actually work together. No any one of them can actually work on their own. And I always include this slide in my presentation to keep reminding students and audiences on the importance of the interrelationship between the three. As much as we can have the best health with the best health programs, if the nutrition and the genetics are not coming to the party, we're not getting a well-oiled machine working. The same if you can just replace any one of those aspects that I've mentioned. So in terms of introduction, I try when I speak to people that we try and familiarize ourselves with the terminology also that we use. Some people use exotic bovine leukosis and bovine leukemia virus interchangeably. And I try to once in a while to bring the discussion back to the fact that not all BLV positive herds are necessarily leukemia herds, because if you actually think about it, or exotic bovine leukemia herds, if you think about it, only a very tiny proportion of BLV infected animals progress to a clinical form of the disease. And yes, like with many other diseases, we've always been concentrating on the clinical disease, even when we talk the economic impact of the disease, and not really focusing a lot on what the subclinical form can actually do to a business or to any business's bottom line. So the terms that are normally just commonly used here, I've got bovine leukemia virus, lymphoma, malignant lymphoma, lymphosarcoma, BLV, exotic bovine leukosis, or even loosely referred to as cow cancer. We have also other forms of a lymphosarcoma that we get. There's a juvenile lymphosarcoma, a thymic, and a cutaneous lymphosarcoma. All these last three that I've mentioned, actually none of them have anything to do None of them have anything to do with bovine leukemia virus. I'm going to try and stop the video so that this thing can try and flow a little bit easier on other people as well. This is the structure of the virus, actually what it looks like. And as we go further, we can actually describe it as a Delta virus from the Retroviridae family, subfamily Orthoretrovirinae. It's been around for a while. The virus was actually identified as far back as 1969. And I think this is also becomes important when we start talking things like, so what? We've been living with the disease for so long. Why now? Why are we bringing it up now? And then we'll get to those discussions as to why it will probably become even more important as we go along the way. It's closely related to the human T-cell leukemia virus type 1. There's also the primate lymphotropic viruses 1, 2, and 3 in the same group. In the veterinary space, other retroviruses that you can think of as your Jachsite, your equine infectious anemia, as well as your caprine arthritis encephalitis in goats as well. The disease over many years, with all the work that has been done, it's been historically known to be in 10 genotypes until around about 2019, when there were authors, you and the team, identified the 11th genotype. The genotype 1 is the most widely distributed globally. And we will also get to talk about why it's actually important to even work on the phylogeny viruses as well. Just in short, in terms of epidemiology, I should have actually put the horizontal on the left-hand side, so we highlight the fact that it's actually the most important mode of transmission by far. That happens through direct contact, whether it's blood, exudates, tissues that enter through a broken skin, or we can even say most of our physiological fluids. But as a veterinarian, where you're obviously going to be involved, will be with things like dehorning, tattooing, minor surgery, mass blood sampling, and probably a lot more times on dairy farms with rectal examinations. There's also a role that has been reported as played by tabanid flies. Mosquitoes, there was a question mark, and mosquitoes in a lot of papers have been excluded purely based on their sheer size and feeding patterns. So if we're talking blood-sucking parasites, we probably can start looking a lot more on tabanid flies because it has been confirmed, but I'm not aware of anything that has reported anything really meaningful in mosquitoes. You need about 1 microliter of blood from a persistently lymphocytic animal to cause an infection. What does it actually translate to? Because I speak to vets sometimes and they say to you, well, when you do rectal examinations, it's not always practical to change gloves with every single animal, but at least try and change gloves every time you see blood on your glove. First, for me, that is very, very vague. No two arms that go behind the animal, they are the same size. And secondly, I don't know how much of a 1 microliter of blood you can actually see on a glove when you're doing routine rectal examinations. I actually try to look for the most practical example of what 1 microliter of blood would represent. Basically, you can take a normal blood drop and divide it 50 times, and you're most likely to be ending up with 1 microliter of blood. So if you take a drop of blood and divide it 50 times, you may or may not be able to see anything at all. So for me, changing gloves only when you see blood is not even good enough for me, if I can put it that way. There is vertical transmission that has been reported. Different papers report different degrees, but definitely in utero, the fetuses do get exposed, but it's still in the single-digit figures that they're reporting. But they also get exposed at parturition because there's a lot of blood also that's involved in the process of parturition. The role played by colostrum and milk has also been reported. In fact, in a few papers that I've come across, there's always a debate as to the importance of colostrum versus the risk of animals not getting colostrum at all. So there would be authors that say on a farm that doesn't have access to any other colostrum except from BLV positive animals, that animal is probably, the calf is probably going to benefit from getting some colostrum from the mother, even if it's infected, versus if you denied an animal colostrum altogether. Unfortunately, nowadays you can actually freeze the colostrum. It can do a bit of denaturization or deactivating the virus, and some people actually also advocate for the pasteurization of the colostrum. To what degree it will still maintain the quality post pasteurization, I do not have much experience on. And also with mastitic animals, we also of the belief that if you have mastitic animals that are BLV positive, they are more likely to be shedding the virus in the milk than non-mastitic animals. And the role played by semen in this specific case has also been mainly in cases where semen has been collected under conditions that produce a little bit of trauma to bulls, which often happens when you collect semen, unfortunately. So if you have cases where there's a bit of blood and there's a bit of bruising and trauma during semen collection, if you have a BLV positive animal, there's a very good chance that you will actually get some of it in that semen as well. In terms of distribution, it's on all continents except the Antarctica. So one could actually start arguing that, but the disease is all over, why make a big deal out of it? We will also get to addressing that. At this stage, I think it was around about 2017, by around about 2017, at least 22 European countries were declared free of disease. So they have successfully eradicated it. Yes, the conditions are not the same. It cannot even be a copy and paste if we want to look at what we can do in South Africa from learning from what they did. And there's about 7 European countries that are currently not free of the disease. The free countries are mostly in Western Europe. We do have it on the continent. There's a couple of authors that have actually reported on the disease in a few African countries, but my interest was a little bit more zoomed into South Africa from the rest of the world. And there is some work that was done by Dr. Sean Morris, Dr. Mohamed Mula, Dr. Ndou at the University of Northwest. Around about 2011, they published something as well. An interesting paper that I came across also, Professor or Dr. Suzuki and Chapman at the University of Cape Town recently did a phylogenetic or phylogenetic analysis from a few infected herds that they picked up in the Eastern Cape. It was actually a few animals that were submitted for analysis, or samples that were submitted for analysis. And in South Africa so far, we have the genotype 1 and 4. And like I said, when we started, that the genotype 1 is the most widely distributed globally as well. In terms of the pathogenesis, there's a couple of things that do happen when an animal gets infected. You may have those animals that will get exposed and do not get any infection, or do not develop any infection for various reasons, whether it's insufficient exposure or whether it's animals that may even be immunologically in a better position, whether it's them being healthy or whether it's specific bloodlines or specific alleles in an animal that makes it resistant to the infection. Like we get individuals that are resistant to certain infections. So you will also get a latent carrier stage where you're not going to pick up anything on an animal that the animal is infected. Then we get animals that become permanently infected. That would go and probably go as far as developing either a benign or a very pronounced B lymphocytosis. And then you will get the far end of the scale where a few of these animals will cross over to a malignant lymphosarcoma. And the malignant lymphosarcoma will actually be the ones that will give you a clinical presentation of these thin animals that are looking in very, very poor condition, as well as a generalized lymphadenopathy that you can pick up on these animals. The picture on the right I actually got from Dr. Jan Duprier. So this is a local picture of a dairy farm where animals were actually starting to go down with a clinical disease. And like I said, it's only a small percentage of animals that will actually get a clinical leukosis. But we need to actually start interrogating what the subclinical infection does to a dairy business, or to any business for that matter. We tend to see the leukosis a lot more also in dairy animals than in beef animals. And one of the theories that actually have been put forward is the fact that it's the difference between the different husbandry systems. With dairy animals, we tend to handle them a lot more than we handle beef animals, for example, which will increase the exposure. And if there's also a role played by flies, we tend to congregate them a lot more than we would congregate beef animals, obviously with the exception of feedlots as well. But then again, with feedlots, we slaughter them so young that they probably are not going to be anywhere close to showing clinical disease in as far as a lymphosarcoma is concerned. I got these pictures also from a dairy vet in the Western Cape, a highly experienced vet that has had to deal with a bovine leukosis outbreak in one of his herds in the Western Cape. And this is what it would present like when you actually open the carcasses. You will find that generalized lymphadenopathy as well. Quickly getting to the diagnosis. It's always been, especially for export purposes, there would be a lot of serology that gets done, as well as the EGIT tests that are being carried out. But I think one of the reasons we probably have not tested enough animals in South Africa has a lot to do with the cost as a limiting factor. It's not a cheap test to run. So a lot of guys would do it only when they really, really have to. And for specifically for this discussion, we actually came across also a different type of test. Other than the ELISA, there was also a bulk milk ELISA that we used for the study that we conducted a few years ago in South Africa. And then there's also PCR that is being used also to diagnose the disease. A lot of times we talk about immunosuppression and the effect of immunosuppression on animals. But in this specific case, there's a couple of papers that I've actually pulled where the work was actually done to demonstrate that animals that are infected with BLV, it's not enough actually to count the economic impact just at looking at the disease, because it has a way of impacting other diseases as well, or animals' resistance to other diseases as well. The first one at the top there, they demonstrated a reduced Ig2 antibody production to J5 vaccine in BLV-infected cattle. J5 is actually an E. coli vaccine. So this would have been on a dairy, and they did a comparison of how the animals reacted to the E. coli mastitis vaccine. I would imagine with something like an E. coli vaccination on a dairy farm, it is not a cheap intervention. You get a lot of guys that are really battling with E. coli that have no choice but to use a vaccine. And this is not like any other vaccine that you will give as a once-off, or even just give a once-off and a booster and then do only just the once-off annual booster. The last time I checked, a vaccine like this probably has to be given at least 3 to 4 times before you get considerable protection from this vaccine. So you can imagine if an animal is carrying that immunosuppressive weight of co-infections with other things, that vaccine may actually end up not even benefiting you the way you're supposed to be benefiting from a vaccine. There's also another study by Emanuelson in '92, where they actually found a positive correlation between BLV infection and the incidence of mastitis. And I mean, you can even just stop at mastitis and say, what does mastitis actually cost a dairy farmer? If you're in the dairy business in terms of diseases, mastitis is probably your enemy number one, because it has a direct impact on what you're actually getting from your animals. And of course, when we start having hoof problems in a dairy situation, they need those hoofs to actually walk to the parlor, to walk to the feed, to walk to the water, which actually has an impact on your profitability as a business if you start having long-term unresolved lameness issues. Gastroenteritis, bronchitis, those are actually pretty much straightforward as well. In fact, while we're still on mastitis, there's also a paper that I came across where they actually found the virus in the alveolar cells of the udder. So if you actually find it in the udder, there will be a way it has some form of a pathological impact on the udder functioning as well. And then there's a few other studies that were done. One included a ringworm in animals, and immunocompromised animals, like BLV positive animals, tend to take a lot longer to clear infections like ringworm, and this was just one of the examples as well. So there is definitely a proven impact on even vaccines that we traditionally use on dairy farms, or whether it's on beef farms. And you as a veterinarian, as a practitioner out in the field, this is where we probably need to start engaging more and say, the traditional vaccination programs that we've been taught about, as they stand, are they enough? Do they need to be modified? And if they are modified, where do we tweak them? Obviously, some of the vaccination programs are drawn with an assumption that everything is okay. We are assuming that a normal herd should not have or should not be carrying any unnecessary burdens. But now we know that we have a disease that is probably very widely distributed even within our herds. What does it actually translate to? If we're going to give our vaccine or our animals a vaccine for a certain disease, is one shot enough? Is it economically more sensible to actually modify our vaccination programs and those that we can give and increase the frequency a little bit more? Can we even justify it? And that's obviously more work that will probably have to be done at some stage as well. One that becomes actually quite key and of interest for me is when we're dealing with a disease like brucellosis, for example. We know that the brucellosis that we battle with in the country, a lot more of it has to do with non-vaccination. But how do we actually explain to a guy that has been faithfully vaccinating his herd year in, year out, whose BLV status is unknown, and suddenly he starts battling with vaccination? You know, when someone says, I vaccinate my animals, I don't make a mistake, but I'm still getting brucellosis coming through in my herd. Should we actually start looking at the possibility that even people that are doing everything right on their operations, there is something else that we can start looking at to say what burden, what other burden, what additional burden are the animals carrying that's interfering with the response to vaccines. And what I've actually put here, it's just a table that summarizes all the different studies that I've come across that show the alteration in the immune function of BLV infected animals. And you can actually see that none of them actually includes anything. I think the last one here was in 2013. And it doesn't mean that between 2013 and 2020, nothing has been happening. So that list is actually most likely to be growing longer as we go along with increased interest on the disease as well. I came across this paper that was actually talking the economic impact of the disease, and they estimate in the US alone, they lose about 285 million the producers and about 240 million US dollars for consumers. And as you can see, this is work that was reported 6 years ago. So the figure might actually be a little bit different. Yes, the US has 9 million dairy cows. Can we extrapolate the figure there for South Africa? Maybe. So at least what we know is that the disease actually does cost a dairyman, whether we like it or not. And the subclinical impact of BLV on cow longevity in this study was not even included, because we know how long an average dairy cow lasts in South Africa. So from a time when the animal gets infected, there's a very high likelihood that the animal will get culled for other reasons that may not necessarily be related to your clinical leukosis, for example. However, we're not ruling out the possibility that the animal may even have gotten mastitis because the animal wasn't immunocompetent enough at the time of exposure because of an immunosuppressive effect like BLV, for example. And I need to mention that BLV is not the only immunosuppressive virus of cattle. There's actually multiple immunosuppressive viruses that one can talk about. We don't leave BVD behind when we talk about immunosuppression in cattle. But you sometimes wonder with BVD, is it actually most immunosuppressive than BLV? Or is it getting the airtime that it's getting because the animal health industry has a solution and there's a commercial interest on it? If we talk about a vaccine, for example, for BLV, in contrast, there's a lot of work that has been put into BLV vaccine development. But with BLV being a retrovirus, and we know many other retroviruses that the world is battling with and has not succeeded in developing a vaccine, the prospects of success with the BLV vaccine production is not going to be anytime soon. Well, we hope it does become sometime soon, but we know that there will probably be a vaccine for HIV long before we get a vaccine for BLV as well. This is a poster that I presented at the Faculty Day in 2017. It's available on UP repository. It actually just summarizes local research findings. Dr. Will Gratuk and I did this study together where we were looking at the herd prevalence and he was looking at the risk factors associated within the herd. It was supposed to be a national survey where we were testing bulk milk samples, but we ended up with only 5 provinces. So that was the old Transvaal, or Gauteng, Mpumalanga, Northwest, Gauteng, Mpumalanga, Northwest, and Limpopo. And then we had a few volunteers also from the Free State that helped us out with samples as well. So like I said, basically to estimate the proportion of commercial dairy herds, if you actually think about it, a disease like this, I've been in environments where we start talking with senior colleagues that have different opinions, and some people say, well, there's no treatment, there's no vaccine. Why don't you spend the energy on diseases that you at least can do something about? But if you actually think back, if you look at literature, there are probably many other countries that have done the same mistake. If you look at what the prevalence looked like in the US around the 60s, 70s, they had like 10% prevalence in their dairies. And then you got to a point now when you look at the various literature, the US dairy herds, we're looking at about 84% prevalence in their dairies. Their beef is still on the lower side. I think they just over 30% herd level prevalence in the US. But it just tells you that in any situation, in any way, if we choose to ignore the fact that the disease is there, it may raise its ugly head in a different form or catch us later on in a different form. Especially when we start having reports around the zoonotic potential of a disease, then it becomes even a lot more sensitive as to where are the vets, what has your role been as a vet in educating and communicating about the disease as well. Okay, like I said, the other part of the study was to look at the risk factors associated with the herd level infection, some of them being the most obvious. So for this specific one, Dr. Gradwick actually compiled questionnaires and received responses from farmers as well, but I will not be reporting on that for now. So I just want to focus on the head, at the head level infection there, or at the prevalence at a high level of herds there as well. Okay, the materials that we did, we had about 155 dairy herds that participated in this study. We had questionnaires sent out to them. Not all of them responded, but majority responded by far. And this is the results that we actually got from the prevalence study that we did. So this was a bulk ELISA or a bulk tank milk ELISA test that was sensitive enough to actually pick up one animal out of a herd of 250, for example, contributing to a bulk tank. So if you look at this table, you can actually see that we've got quite a high prevalence in South Africa. But like I said, we need to take it in the right context and say this is the number of farms. It doesn't necessarily mean a province that has 100% prevalence in the participating farms. It necessarily means there's a high within herd prevalence. Obviously, the next step is to now get into those herds and say, what do the individual animals look like? What control mechanisms would be feasible? If you have less than 5% prevalence within a herd, how practical will it be for you if we say just get rid of the animals? Or if you have a very high prevalence within the herd, let's say more than 50%, we're not going to expect a farmer to get rid of 50% of the milking herd overnight. How do you actually protect others that are not infected from getting the disease? And that's where we start talking now the test and segregate strategies versus the test and slaughter at very low prevalence, for example. What we found, obviously, is the fact that the infection, not EBL, but infection with BLV is widespread. 92 to 99% of the herds that were tested. And if one has to look at the practices that are being used on farms, we did look at what could actually be increasing the risk on the farms. Like I said, a lot of it is things that we know already. So the disease, we know that it is there, it is a challenge, or the infection is there, is a challenge. How do we move forward from here? How do we handle it? And the next slide actually talks to zoonosis. And the reason I'm mentioning zoonosis is because whether we like it or not, the big picture here is that 60% of emerging infectious diseases globally are zoonotic. So whether we're talking about bovine leukosis, today it can be bovine leukosis, tomorrow it will be something else. But we cannot run away from the fact that there is an animal-human interaction at play, and we need to do something about it. We actually going on a brucellosis drive. We know about brucellosis and its zoonotic impact. We cannot run away from it. If it has been proven, if it is proven with more and more work that is being reported, we're going to have to get to a point where we also have to roll up our sleeves and say, what is it that we have to do? What do we have to communicate? Is BLV itself zoonotic? I don't want to dwell too much on the zoonotic potential or what has been reported, but if you do your own Google search, you will see there's a lot of research that actually has been published, ranging from DNA that's been isolated, BLV DNA isolated from breast tissue of breast cancer sufferers, but then as a scientist, you still have to ask yourself more and more questions. There are countries that have reportedly eradicated disease. Do they have less breast cancer after they eradicated the disease? Or is their breast cancer actually worse than people that have BLV in their herds? You can even roll it back a few steps and say, before we even start talking cancer, what actually causes cancer, before we even start talking infectious causes? For example, I came across a paper that says actually, it was a 2008 paper that estimates only about 16% of cancer cases have an infectious origin. So it means actually that the other 84% have got nothing to do with infectious causes. Yes, do they play a role in the etiopathogenesis? Yes, possibly, maybe. But if we actually start peeling it apart and grasping the context that only about 16% of cancers have an infectious origin, we have to now start going into that 16% and say how much of it is actually bacterial, how much of it is viral, and how many viruses do you actually know that can cause cancers in humans. Then you realize that there's many other diseases that we can actually worry about. There's actually quite a list of viral causes that have been implicated in zoonosis or as playing a role in the development of cancers, and not only breast cancer, but other cancers too. Yes, we've got all this information, and there's probably going to be more information coming through. So you're probably sitting there and wondering, yeah, you've got all this, but so what? The disease has been around forever. Why now? But the reality of the matter is often the rules of the game are not within our sphere of influence, whether as veterinarians or as everyone involved in the dairy industry. If you think about it, when more influential players in that space get a grip and win the war on disease, and by the way, some countries are busy trying to eradicate the disease. So if it's countries that we're trading with and they start making it a trade condition when we start trying to export dairy products to them, it will be so far easier. So it will be so much easier for them to exclude our producers based on conditions that suit only them on the other side. I would even start looking at a disease like this as a technical barrier to trade. I mean, we all know the focus and the attention that BSE got as when mad cow disease was at the height of the media attention and everything, despite the fact that the number of people that succumbed to the disease was actually a very tiny number in comparison or big picture speaking, until some of the big players in the industry started diagnosing the disease in their own countries. Then you realize, and we can talk about many other diseases, it's actually not the only one. But should it be that a disease like this, it is actually proven to be zoonotic? We also know that disease control is easier achieved in the animal population. It will probably be far much cheaper if it gets to even a point where it becomes a controlled disease and government puts all the effort into controlling the disease in the animal population, like we would do with any other disease outbreak, like we would do with brucella if it starts getting or becoming a serious headache. We know that it will probably cost us a lot less if we try and manage it in the animal population than have to start worrying about sick human beings that have been exposed. As a veterinarian, that is also about to qualify and enter the industry. It's in your interest also that you stay up to date with regards to the economic impact of the disease and what is it that you can do as a veterinarian out there. Understand the risk factors that heighten the within herd prevalence. It doesn't help to be sitting in retrospect thinking what role you could have played in a herd where the disease has spread. It's not a disease that spreads very rapidly, but with men involved in the epidemiology of the disease, you can inadvertently also play a role in speeding up the rate of spread within a herd if we play ignorant around our dairy farms. There's a couple of suggestions that also came through as to what is it that we can do in as far as management practices to minimize the transmission. And this is specifically for herds that are already BLV positive. Even if you picked up a few animals, how do we slow the disease down? How do we make sure that we do not spread it to other animals that didn't have it? You could possibly even look at testing the animals and isolating, keeping them as far as possible apart as well, the negative and the positive animals. Try and use a sterile hypodermic needle for each cow. Yes, it's not always practical when you have lots of animals to work with. Sometimes we say, okay, if you're going to be dealing with a lot of animals, at least try and change your needle as often as possible. But it cannot really cost you such a lot of money if you just have to boil the needles by the crush side there. Have someone there that's busy sterilizing, then you're not going to spend a lot of money with sterilizing needles if you're just boiling them. And if it's for the benefit of the farmer, I'm sure it will be understandable why you want to be doing that. Try and clean and disinfect blood-contaminated equipment used for dehorning, tattooing, supernumerary teeth removal, or even surgical procedures between animals. In fact, with the second years, we started having interesting discussions around procedures like dehorning. Is it even necessary to leave animals to dehorn them at the time where they're likely to bleed? If you have an option to actually apply the dehorning paste, that can be a completely bloodless exercise. If we switch from cutting horns and producing blood all over the place and replace that with the use of a dehorning paste, wouldn't that actually make a dent in as far as disease transmission is concerned? And that can be applicable with any other disease, not even specific to BLV. The dehorning paste, it's always been a controversial one for a number of years for a number of reasons. But that dehorning paste, in good hands, in hands that know what they're doing, it can also do a very decent job in taking care of dehorning in young cows. Tattooing as a way of identifying animals, we can do a better job by just disinfecting our tools in between. And one of the most practical things that we sometimes talk about is sometimes it's not good enough spraying a disinfectant on your tools. We have to now start talking about the different disinfectants. Do we know enough about them? How much contact time do they actually need with that tool for us to consider it properly disinfected? Would you not benefit a little bit more if you carried more than one of these tools, so that while you're busy using one is busy benefiting from increased contact time with your disinfectant? Get them in a bucket and keep rotating them while you're going between your animals. And at any point in time, if you can make sure that whether it's a nose plier or it's your any other thing that makes contact with an animal that needs to be disinfected, go out there with 2, 3, 4 of them and keep them in a disinfectant and keep switching them all the time when you are working. And you will actually be doing a lot of good in as far as hygiene practices are concerned as well. Use a new or cleaned and disinfected reproductive examination sleeve for every cow. This is actually talking more to rectal gloves and things like that. I mean, if you think about the cost of a rectal glove, or if it makes it even easier, farmers can even buy the rectal gloves themselves if they're worried about the cost. Or at least if you know the status, the BLV status of the specific group of animals that you're working with, you can if you're 100% sure there's no infected animals, you can maybe take a chance with some of these. Control of stable and other biting flies. In making an impact on this disease, sometimes it may be something as simple as modifying your dipping programs. What products are you using? Is it products that can do your ticks as well as your flies? Do they have that long residual effect that you desire in flies? Are they environmentally friendly products that you can use repeatedly without worrying about accumulation in an environment? There's a paper, even though I didn't finish reading it, that was mentioning cyromazine safety profile, for example, in the environment. One of the things that you can add here also is minimize contact between newborn calves, as well as BLV positive animals. Avoid feeding unpasteurized colostrum from BLV positive animals to newborn calves. So you can actually create your own BLV negative colostrum bank, or you can even use a colostrum replacer, the powder that's commercially available if you're not so sure. Because if you're going to be using a BLV positive colostrum, there is definitely a risk that you will transmit it to calves. I've mentioned the segregation there. One can also even cull a BLV positive cattle, especially those with lymphocytosis. Different tests, different papers that we've come across, they've actually started even quantifying like when we're talking HIV, for example, they will be talking CD4 cell counts, and when you get to a certain level where you have undetected or undetectable virus levels, it is also possible in cattle to have those animals that are considered to be low proviral load cattle versus the high proviral load. The low proviral load cattle are known to be a much lower transmission risk within the herd in comparison to animals with a higher proviral load. As a researcher, as a scientist, also when you go out there and you start seeing these things, there's a couple of questions that you also think about as a researcher. Has the investment in better genetics actually cover up what could have been worse with diseases like BLV or diseases like leukosis out in the field? Is the production efficiency enhancement that we're using cushioning the impact of some of these production limiting diseases? I mean, we know, for example, that the dairy cows that we had 50 years ago in comparison to the dairy cows we have now, they produce probably a quarter of what an average cow produces today. So we've done a lot of improvements on our genetics. We've fine-tuned, we've improved nutrition. We've done all sorts of also health enhancement interventions there. But as things get better and we get Rolls-Royce genetics, are these the Rolls-Royce that can take us into the future? Are they able to take the hammering from the environment? Are they able to deliver on the expected extra output sustainably? On the genomics there's certain cattle that have been identified to be a low risk animals in terms of their role in the transmission chain. We probably need to look at more phylogenetic analysis. I've also mentioned the traditional, what it actually means for our traditional vaccination programs. There's no question as to whether there's a need for us to test some more. We can perhaps take advantage of a Brucella wave that is currently taking over the country and say, maybe some of those samples, when you have them, test them for BLV while you edit. A take-home message when I'm wrapping up now, I've got a picture there of a leaking bucket. This is what you can actually look at when you get onto your dairy farms there, where you see those elastoplasts, at least the holes in the bucket that we can do something about. Go out there, prevent diseases that can be preventable. Those that we cannot do much about it, at least don't worsen the situation. If you're filling this bucket up and you know there's holes on the side, do we throw our hands up in the air and say there's nothing we can do? Or do we fill the bucket up a lot faster than it's leaking? I think this is just a quotation from my colleague. I'm going to end here. And I can say we have definitely a high prevalence of the disease in South Africa. Test and slaughter is probably not an option for us, but we can all work together in making sure that the disease does not spread or we minimize the risk. Thank you so much, Eliane. I'm going to give back to you.
Thank you, Dr. Sello, for your presentation. We've got one question that came in asking whether you think that AI might have played a role in the prevalence of EBL in dairy herds.
Well, the risk analysis that Dr. Will Gratwick did on his piece of the research actually mentioned AI as part of it as well. But basically, it's probably around the hygiene side of it. If it's just pure AI and it comes from animals that were tapped without any trauma, any bruises, and the animals are healthy animals that are not infected with BLV, I don't see how that will be a problem. But of course, any disease that you miss and it ends up in the semen, by AI, you can actually take it further, faster, definitely.
Okay, and then there's another one asking, how is the situation of labs that are able to do BLV diagnostic tests in South Africa, and do we have at least one lab per province?
Well, that's an interesting question. I know that with a little bit of the testing that has been done, I'm not sure about other labs, but I know that the ARC OVI has been involved in testing animals for export. For our specific study, we used a lab at tropical diseases, but that was the bulk milk that will probably not be used for export purposes. But more reliable testing, I know, has been done by the OVI. If there's colleagues from DAF that know a little bit more about other provincial labs, they could probably chip in there.
Okay, Dr. Sello, thank you so much. We are spot on. Oh, Dr. Chris, would you like to ask something?
Yeah, it's just quickly, Sello. Yes, most definitely. I think it's a problem, you know, the laboratory diagnostics. Thank you for your presentation. I think we need to be aware of this emerging problem. It's already here, but it's, you know, it's becoming a bigger and bigger problem. This is one of the things that we will address, you know, under the Animal Health Forum, you know, and also under the veterinary strategy. Laboratories and diagnostics is one of the things. At present, we're busy fighting brucellosis. We've already got, and Alicia will tell us now, we've already got accredited laboratories in all the provinces except in the Free State. And then that, you know, that's one way to counter a disease. Then just a question, Sello, on the ELISA test, is that from Symbiotics, is that still available in the country or not?
Chris, we imported what we needed for the study. I don't know if Zoetis has it commercially available in the country. The test kits were sponsored.
Yeah.
But I think there has since been other labs that also produce the diagnostic kits. I don't think it's only the Symbiotics now that's commercially available. IDEX might have something, but I don't know about IDEX South Africa.
Yeah. Now, okay, I will follow up on that one, because the problems, you said it's very sensitive, but 250 cows is about, you know, 20 liters a day is about 5,000 liters. You know, there's not many, most of the herds will have either 2 or 3, 20,000 liters per day, you know, that they will, you know, there's some dairies that's milking 100,000 liters per day. So it's going to be a problem to pick it up there. But I think, you know, for surveillance and then also to see what is the extent of the disease in the country, we will then also get yourself involved, you know, within the environment of Animal Health Forum, and we'll take it further there. Thank you.
If I can say one last thing, Eliane, I didn't mention this during my presentation, the fact that There's other countries that are living with the disease at very, very high prevalence. And in fact, I came across a paper recently that 100% of large herds in the US are actually BLV positive. So it's not the end of the world.
Yeah. Okay. Dr. Sello, thank you for your presentation and answering all the questions. It was extremely interesting, and it is quite a relevant topic today. So thank you.